From the beginning of time, we have dreamed of a world where art could define our reality.
Where our dreams can play out before our eyes.
So, HoloTouch is a framework for design thinking. Ultimately, it's a way to coordinate events between virtual and physical spaces. So there is no HoloTouch device as such, but rather a class of HoloTouch devices. Let's make this a little more concrete. So, HoloTouch systems have three components. A mixed reality enabled device such as a spatial computer or potentially even a phone, microcontrollers, and actuators. So the mixed reality device that we chose to use for our HoloTouch project was the Magic Leap. And this is a spatial computer that just mounts on your head just like this. And it displays 3D elements overlaid on the physical environment. So the second component that a HoloTouch system requires is microcontrollers. In ours we use two, the ESP8266 and the PCA9685. And the last component that a HoloTouch system needs is an actuator. So, bringing it all together, what a HoloTouch device does is use a mixed reality device, such as a spatial computer, to overlay 3D objects in your physical environment. It then relays information about your interactions with the 3D objects to microcontrollers, which issue commands to actuators, which replicate in the physical world your virtual interactions with the 3D object. Here at UF's Digital Worlds Institute, master students Austin Stanbury and Ines Said developed the theory and application of HoloTouch devices.
We wanted to find out if interactions with virtual objects in virtual space can impact real objects in the physical world, thereby linking the physical world and the virtual world. Let's check out the lab. So, let's talk about mixed reality. In most mixed reality systems, 3D objects appear in your environment. You can touch them, resize them, move them around, and that's about all. HoloTouch seeks to enhance mixed reality. To understand what HoloTouch aims to accomplish, we need to look at a few examples. For that, we'll use this Magic Leap and this disposable cup. In our nomenclature, there are two types of HoloTouch interactions. Type 1, replicated interaction. Type 2, simulated interaction. Replicated interactions look like this. If I have a virtual cup right here and I move it this way, the actual cup will move along with it. Simulated interactions look like this. If I had a cube right here and I hit the cup with it, the cup will fall. We'll need to talk about digital post-scarcity. Let's hear what Austin has to say.
Just as the internet ended scarcity in the music industry by allowing people to copy files endlessly, HoloTouch reduces the scarcity of ourselves by allowing us to project ourselves into other places in ways that have always been impossible. For example, you could perform a live piano recital on a piano on the other side of the world. Or it could let you sit down at the table and eat dinner with your family in another state, or even another country. Obviously, those possibilities haven't been realized yet. But let's take a look at where we're at so far by looking at the project that we built with our HoloTouch system. HoloKeys is HoloTouch design applied to a piano. When a user enters mixed reality through the Magic Leap, they're greeted with a virtual version of the keyboard they'll be playing in real life. Reaching out and squeezing a virtual key depresses the physical key on the real piano. HoloKeys is mounted on a custom rig designed for portability and versatility. The key pressing mechanism is flexible and can accommodate many systems. Hardware is mounted internally and power is supplied externally. The system has a 1-octave range. Users operate the keyboard completely remotely from anywhere in the world. Our system pushes the limits of mixed reality and demonstrates the viability of HoloTouch thinking. In this section of the video, we'll cover the hardware aspects of our HoloTouch device, HoloKeys. We used a variety of microcontrollers, servos, and input devices in order to create our project. We will discuss how these devices work together, as well as technical challenges that we faced, like controlling 8 actuators at once, or finding a power supply big enough to power them all. We use the Magic Leap as our primary input device. The Magic Leap actively scans the user's surroundings and builds a mesh of their environment. We use the Magic Leap's gesture recognition to build a realistic user interface for pressing piano keys. When a key is pressed, the device relays the information over the internet. We'll talk more about that later. The ESP8266 is a Wi-Fi enabled microcontroller. This device served as the bridge between our Magic Leap input device and our actuator output. However, there were not enough control pins for all the actuators we used, and the power supply was too small to control them.
So we had to get creative.
The PCA9685 is a 16-channel servo driver with an external power supply.
This driver board provided plenty of connections for all of our actuators, and its external power supply provided all the power that we needed.
We used a variety of software to make HoloTouch, including Unity, PubNub, and Arduino IDE. We worked together to model the piano in Maya, texture it in Substance Painter, and animate it in Unity. When a key is selected, a message is sent to PubNub to move the piano key and the animation plays. Our code recognizes hand gestures and sends the appropriate message to PubNub. PubNub is a real-time communication API. It uses publish and subscribe keys to enable communication with the service. We used PubNub to communicate between Magic Leap and our microcontrollers. The Magic Leap publishes to this channel, which the microcontroller is subscribed to. The microcontroller reads the message and executes the appropriate function. The Arduino code establishes a connection with PubNub. Then it checks the channel for messages which instruct the servo to activate. When a message is received, the microcontroller sends a message through the servo driver instructing the correct servo to turn, delay, or perform other functions.
As mixed reality grows more powerful, nobody can say for sure where these technologies will lead us. But one thing is certain. HoloTouch can help you be there, no matter where there is.